Today I'm going to show you one of my absolute results in computer graphics. It's a result that was first introduced to me when I was 12 or 13 by my cousin, and I was fascinated, even mesmerized by this result, mostly because how simple it was to understand what was happening, but somehow the result was unexpected. Um, the, the idea is you just, let's start with the rules. You just define 3 points in a plane. Then you can start anywhere. So imagine you have a sheet of paper, you define 3 points in this sheet of paper, and then you just drop your pens in a random position and you start there. And then you just repeat this until you get tired. Select a point at random and then move halfway to the point from your current point and draw a point there. So you just have your sheet of paper, your 3 points, drop your point somewhere, then you just select one of the 3 points at random, move into the middle position between your current point and that random point and that selection, and draw a point there, and then you just repeat this over and over and over. So if we were to do this in Python, let's just set up our plotting system here and define 3 points in a plane. So let's first define the plane. Let's do it with a checkerboard. NumPy dot zeros and dot comma n, and we're going to select the 3 points. They could be totally selected at random, but because it's easier to see, I'm gonna select just the corners. So 0, 0, the origin, the opposite side of the origin, and then the middle of the opposite side of this line. Actually, here is an. We start anywhere. For ease of computation, you can just start in one of the points. In my case, I'll just select the origin, and we're going to repeat this, for example, 100 times. Select a point at random, so let's call it selection is equal to random dot random. Let's do import random randint from 0 to 2. Then the new point, it's going to be the selected point plus the current point and halfway there. And then we just set that point to some different value. Because everything is zeros, put a 1, and that is enough. So this will be move halfway to the point, and this is draw a point there. So if we do this 100 times, and then we just show it. So fig size 100, no, 10, 10. Oh, yeah. This is what we got. Kind of weird looking. Let's do a larger one. What? Let's do even bigger. Oh. So here you can see what happens. This seemingly simple set of rules that took a few lines of code to express resulting in the Sierpinski triangle.